Hello, my name is Callum Knott, and in this video we're going to be looking at setting up an IO-Link master for use with Siemens PLCs. So the IO-Link master we're going to be using in this video is this one here. It's a Siemens ET200 Eco PN. So I think this is a fairly new module that Siemens do. But it's a really simple device. It's just a 4 IO-Link master, which is connected via a Profinet connection to your PLC. So that's really handy because it means if you've got a PLC that doesn't come with built-in IO-Link technology, such as maybe a basic 1200 PLC or a 1500 PLC, or even an ET200 SP PLC that doesn't have the IO-Link card in it, then you can use this. Really nice thing about this is because the communication to it is over Ethernet, you can put it miles away, right? You can have your PLC in one location and this somewhere else and still get IO-Link data. So really useful device. Also amazingly well built. I can't really express to you how heavy this thing is. It weighs more than the whole PLC, so clearly built for rugged environments as well. But this is what we're going to be using. So the first thing that we need to do is to set it up by connecting the Ethernet cable. So the Ethernet cable that you have to use is one of these ones. So at one end you've got an M12 connector, and at the other end you have your standard Ethernet. So I'm just going to plug that in now. It goes into this connection at the top. Okay. Let's get this connected. It's not threading in. There we go. So that's connected there. I'm going to plug this end into my switch, and then we'll head over to TIA Portal and do the setup. I've reset this device to factory settings, so I'll go through the entire process of adding it to your project, setting the IP address, and then setting up an IO-Link device as well. Let's get started. So we'll plug in the device and switch over to TIA. Okay, so we're going to jump into TIA now, and we're going to go through the process of setting up this device. So the first thing that we're going to need to do is to actually configure this device with an IP address and also a name. Because if we don't do that, then the PLC isn't going to be able to talk to it, and we're going to end up with all sorts of communication errors. So that's what we're going to start with. So you'll see down here on the left-hand side, I've got my online access folder open, and here the PCIe card, which is just my Ethernet connection. And if I update the devices, just to show you what's there, we see I have 2 devices currently connected. I have the PLC, which is an ET200 SP, and this is sitting on the IP address 172.21.0.2. And then we have one thing here listed as an accessible device. And this device actually doesn't have a real name and also doesn't have a MAC address, an IP address. It only has a MAC address. And so what we're going to need to do is to open the diagnostics for this device. And we have here the ability to assign an IP address and to assign a Profinet name. So we're going to do those 2 things now. So the first thing I'm going to do is assign it an IP address, and I'm going to assign it in the same range as my PLC. So my PLC is 172.21.0.2, so I'll make this one 172.21.0.3, and then the subnet mask has to match. Once that's done, I'm going to click the assign IP address, and that will download a new IP address into the IO-Link master. So that's done, and we should see that update here on the left-hand side, but it still doesn't have a name, and you do have to have both of these things set in order for it to work properly. So we're going to come to this next tab, Assign Profinet Device Name, and we're going to give it a name. So we could call it something simple. Let's go for IO-Link Master. So that'll be its device name. You could call it something better, but that'll do for now, I think. And we have to click down here this Assign Name button. So we're going to click that. There we go. And we should see in a moment, it updates over here, IO-Link Master. So we now have a proper name and we have an IP address. Fantastic. So that's the device hardware kind of configured from a networking point of view, but we haven't actually added it to our project yet. So if we go back to our Devices and Networks tab, so we have an overview of all of the devices in our project, and we then need to find the device from the hardware catalog on the right-hand side. So if you know the exact part number, of course, you could just search for that exact part number, it would come up. Or it's fairly easy to find. This is a distributed I/O device. We know that. We know the part name. And it's this device down here, which is a 4x IO-Link master. And we're just going to drag that and drop that into our project. So we have the IO-Link device, and we have our PLC, but we just need to link the two together. There we go. So now we have a connection between them. So you'll remember that the first thing that we did was to set an IP address and set a Profinet name. We need to check that actually the devices we're referencing in our project match the devices that we have listed down here. So let's first check the PLC. We can open this tab at the bottom, look at the properties, and see, yes, okay, it does have the IP address 172.21.02. That's good, it matches the physical PLC. And let's check the same for the IO-Link device master. If we come up here to the Ethernet addresses, okay, we see there's a problem because this IO-Link device, for some reason, this Profinet device has started with this IP address. We need to make sure that it's actually set to number 3 so that it gets the correct IP address when we download from our project and the PLC knows how to talk to it. The next thing we have to do is just to check the Profinet device name, and you see it's actually allocated one automatically, and I think I would much rather use the one that we have, so we're going to go for IO-Link master. There we go. So as long as that matches what you put in earlier and your IP address matches what you put in earlier, then we should be pretty much on the right track. So that's the initial device configured, and then our project configured to contain that device. Now what we have to do is actually start to think about the IO-Link capabilities here. So look, what we'll do is we'll just jump into looking at this device in a bit more detail. We actually have the same properties down here as we had before, but it's kind of nicer to focus in on the device. So this device is kind of clever. It has 4 ports available on it. Four ports. You can see them on the front here, 1, 2, 3, 4. But these ports can either be IO-Link ports, or they can actually just be standard digital inputs and outputs. And so we have to describe what we want them to be. Do we want them to be IO-Link ports? Do we want them to be digital ports? Or do we just want to disable them completely? So let's have a look at our options here. We have here the IO-Link properties, and we can actually choose here, we've got the 4 ports, we can say we want to enable or disable these different ports. What I'm going to choose to do is to disable any of the ports that I know that I'm not going to use. So I'm only going to use 1 port here, just the first one. If I had more IO-Link devices, of course, I could enable more of them and configure them all separately, but for the purpose of this tutorial, we only need 1 port. So because only 1 port is available, we can see the configuration for it here, port 1. We could change its name and comment for what it's going to do, but we'll leave all of that for the moment. The only thing that's really going to be important here is setting the port type. So I said we can have it as a digital input or a digital output or any of these IO-Link device options. And so what we're looking at here is the amount of address space that this IO-Link port is going to take up. Now, why might you want to change that? Let's say you have something like a really simple sensor. Maybe just a height sensor, for example, analog height sensor. That's probably only going to take up 1 input byte worth of data. So you could come here and you could say, okay, I only need a single input byte. It only needs to take up 1 byte worth of space. The device that I'm using, just for this demo, is this small device here, which is a miniature HMI. It's got a couple of buttons and a little screen attached to it, so it's quite a complicated IO-Link device. So what we're going to do is we're going to say we need more space. So I'm just going to give it 32 bytes of input and 32 bytes of output space. I actually don't know how many this screen needs. I think it probably needs only 16 of each, but it doesn't hurt to have more available. So because I've decided here that there are 32 bytes of input and 32 bytes of output available, up here we see where that is actually addressed to. And so it's 32 bytes input and output starting on ports 2. Now, I don't really like my IO-Link devices to start on 2. I think it's kind of confusing if you've got your inputs and outputs on 0 and 1, and maybe you've got 16 inputs and 16 outputs. It's all a bit too close. So I'm just going to change my IO-Link device to start on 100. Just gives a bit of space, bit of freedom, and a nice big round number. Can't go wrong there. So we have now set up the IO-Link master device to give it a single port with 32 bytes worth of input space and 32 bytes worth of output space. We've addressed it to a nice known location. We have made a lot of changes to this project since we started, so it's time to start to download this and check everything works. So I'm going to do a couple of things here. I'm not entirely sure that they're all strictly necessary, but I like to do it just because I'm really confident then that I'm happy. I'm going to right click on the IO-Link master and I'm going to choose compile the hardware and I'm going to get it to rebuild all. So this is kind of important because any changes that you make here to the ports, the amount of address space that they require, or which ports are enabled and disabled, anything you do like that is kind of a hardware change. So it's a really good idea to compile those hardware and rebuild it all. And then I'm going to download to device, and I'm going to say I want to download the hardware configuration. It's going to ask me to search for my PLC, so we'll just do that. And then we will download. Now this process could take anywhere from 10 seconds to a minute, just depends. There we go, TIA was really quick this time, but that download worked. And now what I'm going to do is I'm going to make sure that I actually download the PLC program as well. Okay, so it looks to me here like everything might be downloaded and talking correctly and hunky-dory. So what we're going to do is we're going to right click on our device again and choose Start Device Tool. And we're going to open a program called S7PCT. So this is actually no longer inside TIA Portal. It's a separate piece of software. It will install automatically with TIA Portal, so it should be already installed for you to use if you're using TIA. The project opens and we see on the top here I have my IO-Link device being listed. And so all I'm going to try and do at this stage is just simply connect to it. And if I've done the hardware setup correctly, at this point it should go online. Great. We see online success. That means that the communication is working between our PLC and our IO-Link device. Everything is set up correctly. This is really fantastic, good news. We have one error message being displayed here, which is just that the device is not accessible. But what this is actually saying is that the IO-Link device is not configured correctly yet. And that just means that I have actually already in this project set up this IO-Link HMI, and it's not connected because I haven't wired it in. It's sitting here, not yet wired in. So if I wanted to, I could, if we just go offline, I could delete that IO-Link device and we could add it fresh from the menu. Now I'm not going to go through all of this. There are other tutorials that take you through adding and configuring IO-Link devices. I'm just going to wire that one in there and then I'm going to actually screw in the device into the master. Okay, so IO-Link device is now connected. I'm just going to choose the download button here. And hopefully what it should do is it should now download that configuration that we've described nicely into my IO-Link master, which means that this should now work and be connected over Profinet. So that's really everything in terms of the tutorial to show you how to connect this device. I'm not going to go through any more changes or anything that need to be made to this device. Everything should now work. What I will do for the next kind of minute of the tutorial or so is just to go about proving that this is connected by just reading some of the input bits. But that's not relevant for just setting up the device. So if that was all you were interested in, consider that the end of the tutorial. But if you want to watch on for just 30 seconds or so, then we should get to a point where I can push these buttons in a watch table and see this data changing. So let's have a little look at that. So this device says that it's got some key indication, and that the key indication, that's these little buttons, tell this error message to go away, should exist on input byte 100 because that's where I set up 100, right? That's the starting point. So let's just close this PCT tool. Yes, I want to save as I close it. Just make sure that the configuration is saved to the project. And if I'm going to go to my PLC's watch table, let's add a new watch table. And let's look at IB 100. Oh, not 0, IB 100. And let's look at in decimal format and let's just monitor this. Then we should see, I hope that as I begin to push these buttons, There we go. We see that the actual display format changes there. Depending on the buttons I push, I get a different monitor value back. So that just proves that the connection is working. I'm getting data from my IO-Link device via my IO-Link master back into my PLC. I hope this video has been useful, and if you have any questions, feel free to put them in the comments. I will try and get back. Thank you.